Hello guys, welcome to the second lesson for your CCNA 200-301. And in this lesson, we'll have a recap for our previous session. We'll look at the various components that make up a particular IP address. We'll also look at what the concept of subnet mask is. And finally, we'll also look at how each particular IP address will perform based on the class it falls in. That's looking at the components for these particular IP addresses from each range or classes. So let's get started. I still remain George Banfo. And previously we had a lesson and we discussed what IP addresses are. We said IP addresses can be synonymous to the name of a person. So I made use of Alice and Bob in our previous lesson. And we also said we have 5 main classes for IPv4 addresses. We said we have a class A, class B, class C, class D, and class E. And we mentioned that for any IP address that we have, typically a class A will start with a 1 through to 127. A class B will start with 128 through to 191. A class C may start with 192 or any number up to 223. A class D will be 224 or any number up to 239. Class E, which is our last class, is starting with 240 up to 255. So let's just move on to what the various identifications will be like. Let's look at examples of IP addresses, and then let's see whether we can be able to find the various classes for those IP addresses. Now, we have a typical example on screen. We have 192.14.2.0. In order for you to identify the class of this particular IP address, the first thing you have to take note of is the first number. And in this case, our first number is 192. Now, again, just so we get it clear, let's look at the various classes and the ranges that make up that class. So class A will start from a 1 through to 127. Class B would be any number from 128 to 191. A class C will be 192 to 223. A class D may be starting with 224 or any number up to 239. And a class E, which is our final class, will be any number from 240 up to 255. Looking at the example we have, the first number is 192. In the ranges, you can see this cannot be a class A, it cannot be a class B. 192 falls in the class C range. That makes this number a class C IP address, because in order for you to find the class of the particular IP address, you look at the first number. The second number we have on screen is 148.17.1.1. And 148.17.1.1, we first look at the number, the initial number, which is 148. So 148 is our first number, and let's consider the range it falls into. It cannot be a class A because class A's could be starting from 1 up to 127. So that leaves us to class B. So 128 to 191, 148 will fall within that range. That makes this particular IP address a class B. The next one is 193, which will be our last example. So 193.42.1.1. Considering the first number, which is 193. So checking our ranges, 193 will fall within this range and make it a class C address. The various examples on screen, and you could do them at your own convenience. So that's supposed to be for this example. So this is for this, yeah. So considering the examples we have on screen, you could pause your video and try and attempt it. If you have any difficulty in identifying any of the classes for these IP addresses, just leave me a comment and I'll respond to it. All right, let's move on to the next thing, which is the various components that make up an IP address. So for every IP address you have, I mean, every IPv4 address you have, it has 2 main components or two main parts. The first part is referred to as the network part, and the second part refers to as the host part. Let's go back to our analogy we had at the first lesson, which was to do with what an IP address is. We mentioned that an IP address can be synonymous to the name of a person. And in our previous lesson, we spoke about Alice and also Bob. Yeah, so these were examples of, say, random names. And we mentioned that these can be synonymous to what an IP address is. Now, let's take a name like John Doe. John Doe, in this case, is like a very famous name in America. Now, John Doe has two names making up the name of that person. One part of the name can be associated with a family. Let's assume this is the surname, which can be associated with a family. And the first part, which will be a person's own or first name. That's what we normally call them. So let's assume everybody has a full name having only two names, one being your first name and the other one being your family name or your surname. The concept of IPv4 addresses can be used in the same way. So the network part can be linked to a person's surname or family name. So let's say family name. And the host part can be linked to a person's first name, which is the name of that person, a given name. Okay, so what do we mean? Let's take a typical example of an IP address. When we say 10.1.1.1, which is an IP address, we're saying that some part of this number will represent a family, and the other part of it may be representing a person's first name. And that's what we'll be looking at. All you have to understand from this particular page is the fact that any IP address can be broken down into two different parts, a network part and a host part. Okay. The next thing we'll look at will be what we refer to as subnet mask. Now, a subnet mask is just something that helps us to know which part of an IP address is the family part or the network part. What do I mean? I mentioned that we have John Doe, and John Doe is a person's full name. So the subnet mask gives you an indication of which part of the name will be your surname or family name. So subnet mask is more like a description to what the network part of an IP address is. Okay, let's see this. Let's say you have 10.0.0. maybe 4. The subnet mask is more like a description that says, okay, this particular part represents the network. So it gives you an indication of which part represents the network. And also, once you're able to identify which part represents the network, we can be able to isolate the part that will be for your host. We'll see how this is done for every IP address class. So as I said, it is that description of a network. It can also tell you how big the network is. We'll see that in subsequent videos. So just keep in mind, for this particular page, all we have to know is that a subnet mask tells you about what the network part of an IP address is. Okay, so in our previous lesson, we mentioned about class A, class B, and class C as unicast addresses. And these are the IP addresses we're going to be using in most of our lessons. And so we're going to focus our attention on the class A to class C. So for any class A address, the subnet mask or the descriptor, the particular thing that tells you which part of a class A address is your network part, is 255.0.0.0. So what I mean is, anytime you see any class A address, any IP address that starts with 1 through to 127, let's say, for example, 15.7.2.1, which is typically a class A address. Looking at what we have here, it's a class A address. Now, anytime you notice that an IP address is a class A address, it comes with a particular subnet mask. which is 255.0.0.0. Again, if you have a difficulty in understanding what a subnet mask is, you just have to replay this video. All you have to know is that from class A to class C has a particular subnet mask attached to it. We'll use it extensively in other lessons, but just for this lesson, you should be able to identify what a particular subnet mask is based on the class the IP address is coming from. The next one we're going to have a look at will be a class B address. So for class B address, the subnet mask is 255.255.0.0. So we also mentioned that class B addresses start from 128 through to 191. So if you pick a typical example like 172.16.1.4, looking at the first number, we can say this is a class B address. And because it's a class B address, its subnet mask will be 255.255.0.0. And that's how you are able to identify the subnet mask for a class B address. First of all, you need to look at the first number. If it falls within that range, then you assign to it the subnet mask for a class B, which is 255.255.0.0. The next one is a class C IP address. So again, a class C IP address starts with 192 through to 223. So any IP address like 200.1.10.254 as a class C address. How did we know? Because the first number, which is 200, falls within the class C range. And for class C range, can you guess what the subnet mask will be? Yeah, it will be 255.255.255.0. We can see a pattern building up here. So for a class A, we saw that the subnet mask started with 255. There was only one 255, and we have 3 zeros. For class B, we have two 255s and 0.0. For class C, we have 255, 255, 255.0. So we can say for certain that class A addresses have only one 255 for the subnet mask. Class B has 2 of the 255s, and class C has 3 of the 255s. Now, what we've been doing is two things: identifying what a particular IP address class is. So identify the class. That's what we've been doing. We're identifying the classes. And also, the next thing was assigning a subnet mask based on the class. So the subnet masks that we've been using are just because of the class we find the IP addresses. The question will be, why are we not talking about class D and class E? Class D and class E don't use this subnet mask. So we are only focusing on class A to C. These are the classes that we assign to individual machines. So that's what we're going to focus our attention on for now. So again, all we've been doing is identifying the classes, and based on the class, we assign a particular subnet mask. Let's see this. We're going to give an example. So our example will be 192.168.1.2. So which class will this IP address fall into? I'm guessing by now we should be kind of familiar with what the classes are. If you have a challenge, just visit the first video. So 192, if you look at our table, 12127, 128 to 191, 192 to 223. Just keep this. You can have this as a piece of paper around you and make reference to it. So 192 falls within the class C range. So we can say 192 is a class C. And what did we say the class C subnet mask was? So our class C subnet mask will be 255.255.255.0. And that is what our class C subnet mask is. Again, what did we say our subnet mask is? We said our subnet mask helps us to see the network path of our IP address. Again, we said our IP address is made up of two parts. Can we remind ourselves what the two parts are? So we said we have the network part and the host part. So the network part is what in our everyday life, if you're using a synonym, which is a person's full name, your network part will be a person's family name, or in other places refer to them as surname. And the host part is just a person's given name or first name. That's what we call it. So you can call it given name or surname. Now, the subnet mask, which we have here, which is 255.255.255.0, should give you an indication of which part of this IP address will be your network part. Anytime you see 255, it's just telling you that that part belongs to the network. So this will be part of our network. This is also another 255. It's saying the second part will be part of our network. And this is also saying another 255. This is also telling you that this is part of our network. If we're saying our IP address is made up of two parts, and we've been able to identify the network part, whichever one is left will be our host part. So in this case, our host part is the 2. So if I'm rewriting this, I can say for certain that 192.168.1 is the network part of our IP address. And the host part is just that 2. And this is the host part. And this is what the subnet mask can help you to do. Let's take another example for our subnet mask and also identifying which particular part of the IP address will be for the network, and the other parts will definitely be for our host. So let's take another example. Don't forget we're considering only class A to class C addresses. So in this example, we're taking 148.7.254.3. Again, looking at the ranges, looking at the first number, this is certainly going to be a class B address. And we mentioned that for class B addresses, our subnet mask will be 255.255.0.0. Now, we said the subnet mask will give you an indication of what the network part is. And I also mentioned that the 255 will tell you that that particular portion of the IP address is part of your network, or it's a network part. Okay, so the first number, which is 148. So if you're taking a look at this, our first number, which is 148, will be part of the network. Why? Because it has, under the subnet mask, it has 255. The second part, which is 7, also has 255. So anytime you see 255, it's just telling you, take it as you being notified that this belongs to the network. So we have 254.0.3. So for our subnet mask, which is this part, it's a 0, it's not 255. So we're leaving the rest for our host. So 254.3 will belong to our host. So if I'm rewriting this and I say 148.7.254.3, we can say for sure, because of the subnet mask, the first two parts will represent our network, and the last two parts represent our host. Okay, so what do we mean by represent our network and represent our host? So when we talk about the network part, what it means is that if your network can be synonymous to your family or family name, then it means if any IP address bears this particular part, if any IP address we see, say for example, 148.7.240.1, it's also a class B address, so it means the first two parts will be our network part. So the two IP addresses, this one and the one we formerly used, have the same network part, which means they belong to the same family, because synonymously, we're saying that your surname is kind of your network, your network path. So if two different IP addresses have the same network path, then we can also say that these two IP addresses belong to the same network, and they can communicate to each other without any worries. So let's pick another example that also starts with 148. So let's say we have another IP address 148.5.4.3. Watch here. This is a class B address. So still, again, our subnet mask will be 255.255.0.0. And for a class B address, looking at the subnet mask, it means the first two parts belong to the network. Can we say that 148.7.240.1 and 148.5.4.3 are in the same network? No, they are not in the same network. And the reason being that for these two IP addresses, even though they have the same starting number, but based on the subnet mask, which is 255.255.0.0, they don't have identical subnet network paths. So we cannot say they are in the same family. So the subnet mask will tell you which parts of the IP address is your network paths. And from there, you can compare the IP address to any IP address and decide whether or not these IP address belong to the same network or the same family. Thank you.